that it just keeps on going. There's nothing to stop it. And so the only thing that's going to stop it is perhaps whatever's out there in the galaxy that kind of forms like, you know, the winds of the galaxy. It's not really winds, but the particles that are in the galaxy around us, our Milky Way galaxy. So where is this boundary? And that's what we call the heliopause. It's kind of where the pressure of our sun stops and the galaxy pressure pushes in. So that's sort of like a border. It's not a hard and fast border. But they did, you're right, Voyager 2 went through it, and they could tell that. But yes, this is all new stuff that they're learning. But you pretty much summed it up correctly. Yeah. Yes.
You really want to say anything about donations?
Yes. Okay. Ready to go? Okay. All right. We're just about ready to go. And Jim, John, I'll let you introduce our speaker. But before I do, the last thing I will say one more time, and thank you for your patience, and thank you for your good questions. My name again is Paul. I'll be around tonight again for membership, so for more questions. The last thing I will say is again, we are donation supported. We get no funds from any place else except our membership dues. There's a donation box in the back. Please, if you could, as you leave, if you think you've had a good time, please put something into the donation box. It will help us greatly. I appreciate it. Thank you much for letting me talk to you. Enjoy the program.
And we're celebrating 50 years. Yeah, 50 years. Isn't that great?
Golden anniversary.
I look that young, huh? Okay. Well, you know, the one disadvantage we have for being above the equator is that we only see half of the cosmos. And so there's really great reason to go south of the equator. And some individuals do. Chile is one site. Our speaker tonight, who is the director of the Boyertown, Pennsylvania Boyertown Planetarium, is fortunate enough. He's one of the few people that was chosen for the Astronomy in Chile Educator Ambassador program. And now we're fortunate enough to have him here. And so please welcome Peter Detterline.
Thank you, and a pleasure to be here with you tonight and to get a chance to talk to you about modern day astronomy, how we connect the cosmos to the Earth, how it's done. My story really began last Christmas. I have off from school, I got a week, I have friends coming in, visiting, it's the holidays. And every Christmas I have a friend of mine who's really into astronomy, and he stops by, his name is Ryan, and he says, dude, yeah, I know, he's 20 years old and he calls me dude. You need to come down to Chile with me this summer. I'm like, Chile, what are you talking about? It's a program called ACEAP. ACEAP. Astronomy in Chile Educator Ambassador Program. They're going to take people, educators are going to take them down to Chile, and they're going to show us some of the modern observatories, optical and radio, including the highest observatory in the entire world. I'm like, wow, and the southern sky. And he's like, and the southern sky. I'm interested. Let's go on the internet, let's check out this ACEAP thing. And I'm looking through it, and I like this. And I said to him, you're applying for this, right? And he said, yeah. You do know they're only picking 9 people. And if I go for this, I'm going full out. And if you get it and I don't, I'm okay with that. But we're going to be in direct competition with each other. I need to know that you're going to be okay if it goes the other way around. And he looks at me like he doesn't understand a word I'm saying. And he says, I don't understand what you're saying. He said, the way I see it, we're doing them a favor because once the 2 of us apply, they only have to find 7 other people. So I applied. And I was fortunate enough to be chosen. Here is our group getting ready to go up to the highest observatory in the world. There I am, and standing next to me, there's Ryan. He was right. We both got in. And what an experience. That's the Astronomy Ambassadors. Why Chile? First of all, everything is brought to you by a number of different organizations. National Optical Astronomical Observatory and Radio, Associated Universities, AURA. But a lot of this is funded by the National Science Foundation, and that's a really big deal. They would take care of everything down there except for our plane flights. So we'd have to pay for all the airfare down to Chile and in the country to go to the different observatories. They would cover everything else. So it was kind of covered 50-50. But why are we going to Chile? Location. That's the big thing. Your location comes up over the Andes. It is incredibly stable. You know, twinkle, twinkling, somebody to stand there, going to take a picture, little kids jumping all over the playground. The atmosphere makes them twinkle. The less they twinkle, the sharper your image. This is why we take things like Hubble and put it out into space. It's not that it's closer. You don't have to look through the atmosphere. That's the difference. And then you can get a nice, beautiful image. Up high, there's not as much twinkling going on. Drops.
365.
There's an optimist.
About how many?
30.
Maybe 30 on a good year, right? At our best observatories in Hawaii, in the northern hemisphere, all those places, 150. Chile, 300. 300 pristine, jaw-dropping, wow, kind of nights a year. This is the best place to do astronomy on the planet. The next reason, location. It's closer than Australia. And it has more clear nights than even Australia out in the desert. Location to do astronomy. And finally, a good stable government. They like doing business with us. They have good contracts. They're solid. There's a good infrastructure. It's a really modern country to move around in. Technology is high. This makes for a perfect place to do astronomy south of the equator. So we traveled to the heart of Chile, Santiago. There's a view taken by Ryan. This is at the top of Cerro San Cristobal. It's a park in the city. And we can look out over the entire city here. A layer of haze. Got some air pollution off in there, but on a nice clear day after it would rain and drop some of that down, you would see the Andes Mountains back there. The town's beautiful, and the people, absolutely wonderful and amazing. As you can imagine, it's the capital of Chile, so it's going to have the largest buildings. This is actually the largest one in all of Chile. It's still under construction. Light pollution in town really isn't that bad. It's really not that bad. It's a beautiful town. It's very safe. It has the largest planetarium in all of Chile there, 200 seats, a nice Zeiss projector. I also have to mention it's the only planetarium in all of Chile. But it's a beautiful facility. That is my idea of riding a bicycle. Telescope in one hand, riding the bike. I think I've tried that at one point or another in my life. But this is a nice sculpture that's down in their park. And you are looking at Venus and Jupiter. That's June 30, right at sunset. We spent a couple of days in Santiago. Orientation, getting to know each other, going through a lot of the things we would need to do. And of course, visiting a lot of the offices. They all are set up right there in Santiago. So the headquarters for the administrators are right there. But it's time to go see some observatories, right? We get on a plane and we fly to La Serena. It's about a 1-hour flight. And once we arrive, we visit the headquarters there in La Serena. Nice, beautiful little town right there off the Pacific Ocean, right on the coast. The observatories have lots of headquarters down there for the administrators, but also labs. There's Ryan. And this little object right next to him, not very small actually, is a camera. That's a CCD camera. This is what astronomers put on the end of their telescope. When we have CCD cameras hooked up here, we go out and we buy one somewhere and we put it on. We try to get the best camera we can get and we put it on this thing. That's not the way it works here. When they want a CCD camera, the astronomers go up and they say to the engineers and the opticians, we want a CCD camera, here's what we want. And they said, okay, and they make it for them. This camera, 7,000 by 7,000 pixels, 49 megapixel camera. There's only 5 of them in the world. They make them right here in La Serena. And a price tag about $500,000. They just make everything that. They got opticians on staff, they've got the machinists on staff, the engineers. They do everything in-house. You can't look through any of the telescopes up there. They don't have places to put eyepieces or the time for people to be looking through telescopes. That's not their purpose. There's no eyepieces there. But when the president said, I would like to have a White House star party, he said, go make me an eyepiece. I said, we could do that. All right. So they made the first White House star party eyepiece. It's inside of there. There's another one. And that was what they used. They said, go make an eyepiece. Make a nice eyepiece for the president to look through at the star party. So that's where it was created. These things in the front, pay careful attention to those. They're called actuators. And what they do is they're controlled by computer and will go up a little bit and go down a little bit, like a piston, up and down, really very smoothly. And they make them there. These guys were all bagged in the back. He's making 124 of them. They'll have to be the same. He machine shops and gets all this stuff together. I will talk about these actuators in a little bit. Let's get out to an observatory. We start with Gemini South. Gemini are the twins, right? So we have Gemini North sitting on Mauna Kea in Hawaii and Gemini South on Cerro in Chile. They're twins. The telescopes, the observatories are exactly the same. You want the same telescope in northern and southern hemisphere. This is going to be the largest observatory I've ever walked in. It is unique. We want to keep the temperature of the air in that mirror about the same, so we need to have some good cooling. At night, these walls will open up. So the walls just kind of disappear to allow cold air to flow through at night to really kind of keep that temperature the same. They dropped them down for about 10 seconds and then closed them up because it was daytime. They didn't want any heat in there. The telescope is absolutely amazing. It's huge. Here we are, all standing out there, all happy. You can see the size of this thing. It's 8 meters across, about 24 feet in diameter. We're happy, but take a look at how we're dressed. It is cold in there. I mean, really cold. They have an air conditioning system that they turn up to crank up to high. Even in the daytime, they want this room really cold. It's better for what they want to do. The mirror, 24 feet across, actually is coated not with aluminum like we have in our mirrors here, very reflective, but silver. It has a coating of silver. You'll find more silver in 2 silver dollars than you'll find on that mirror. But for the thermal properties, silver works so much better than aluminum for what they want to do. And this mirror is only 8 inches thick. That's it. It can't even support its own weight. So it's in a cradle that's going to keep it set so that I can look at the stars. It's not very thick at all. The other thing about the mirror, it doesn't look at the sky the way you and I do. This is a galaxy, the Sombrero Galaxy in Virgo. We've got the edge of the galaxy here. You got the center. Beautiful. This picture was taken by our friend the Hubble Space Telescope, high above the Earth's atmosphere. At Gemini South, this is how they would look at it. Same picture. Look at the difference. Gemini South is not looking in visible light. It is looking in infrared, near infrared. So this is stuff you don't see with your eyes. The difference is you're going to see some more detail along here that you would never ever see visually. So it operates in near infrared. It's going to be looking at wavelengths we can't see. Remember I said the mirror is really thin? Remember those actuators, those little things that go up and down, right? The mirror sits on top of the actuators. And what it does is when the star is out there twinkling around, twinkle, twinkle, little star, they shoot a laser up. And then they hook it up to a computer and they say, hey, make the star behave like the laser. And the mirror starts to shape and deform so that all of a sudden the twinkling stops. It's like the entire telescope is out in space. Hubble is 90 inches across. This is 24 feet. The images through it are absolutely amazing. We call this adaptive optics. And it has the most advanced adaptive optics in the entire world. So here I am at the control room for Gemini. This is it. How do we do astronomy? Okay. You guys are an astronomer. You've got this research project. You want to take a look, let's say, at a galaxy. And you want to learn something about it. So you go online, you set up an application, you send it out to an observatory, and you say, here's what I want to do. Here's the observing time I want. This is what I need. And then a committee looks at it and they say, that's pretty cool. Yeah, we like that. Give him some observing time. And I'll say, we're going to give you 2 days to look at your galaxy. Come on down to the observatory, check this thing out, and you have these 2 nights to work it through. You fly out to the observatory, you go down there, you meet with the staff, you go through all the setup, and night number 1, you've got the telescope, and it's cloudy. Hate that. Night number 2, the clouds have rolled away, it's clear. You're like, yes, I get at least 1 night out of 2, right? 2 hours into your observing run, the camera, and now you sit down to the schedule, and hopefully the weather and the equipment will be a bit better. That's not the way it works here. They don't want you there. You submit your proposal online, the committee looks at it, and they say, wow, we like this. But it's not the best. We're putting it in the system in a 1, 2, 3. It's in the queue, they call it. 1, 2, or 3. 1 is highest priority, 2 second highest, 3rd lowest priority. We're going to give it a 2. And according to what we're looking at, your galaxy is highest up at these times. That's when we're going to image it, only when it's at its highest and best on these nights. Very rare. It's cloudy that night. That's okay. We're going to get the next clear night. We'll pop you right back in the queue. We're rescheduling everything because it's cloudy that night. And all you're going to do is just wait until you get an email saying, we've taken your images, we've done all your stuff for you, it's back here, you can collect it on this website. And all your data can be downloaded to your computer. They find out that this is a much more effective way of getting things done. A lot more research gets worked out due to the queue system. But the astronomers are never there. They don't leave home. Actual image from Gemini South. You are looking at the Orion Nebula. Now you guys are like, oh, really? The Orion Nebula is so famous, and if anyone's looked through a telescope in the wintertime, you're looking at the Orion Nebula, and it is gorgeous. The Gemini telescope, for my astronomer friends out there, is an F-16. If you're not an astronomer, what that means is that the field is really tiny. Really tiny. It'd be fantastic for planets. So you're looking at a really small part of the Orion Nebula. And we see these pinnacles that are jutting out from this. And again, we're in infrared. The blue that you see on here is actually iron. That's iron gas. That's really blasted away from a star. Notice that they're all coming from down here somewhere. So the star's out of the picture, but it's blasting iron gas off of it at really high speed. And as it goes through the hydrogen gas, it creates these pinnacles as it heats it up as it goes through, like bullets shooting off of this thing. That's interesting. We're learning a lot about how stars work stellar formations. I'm in college. Sophomore year, taking advanced astronomy class. My professor is up there and he's talking about this observatory in Chile called Cerro Tololo. Cerro Tololo, and I'm writing this down in my book, Cerro Tololo. He spent time down there on a 16-inch telescope. He talked about the 6 observatories that they had. The astronomers moved around in golf carts, the incredibly clear nights, and the large number of foxes running all over the place. We would get to spend 2 nights there living at Cerro Tololo. This was going to be phenomenal. These were the 2 nights I was really looking forward to. The 6 telescopes have now turned into 35. It looks like a mushroom farm. Domes everywhere, 35 of them. They don't have the golf carts anymore, but they still have the amazingly clear, still nights and lots of foxes all over the place just ready to pose for you or looking for a handout. Some of the telescopes down here are automated. Universities have, these are 1-meter telescopes, 40-inch telescopes in all of those. And every night they just open up automatically, start to point to the sky. There's some student at the University of Michigan and the University of North Carolina who are operating some of those telescopes. The larger ones, they want the astronomers there. We do it the old-fashioned way. If it's cloudy, you're just out of luck. We like having you down there. They got dormitories, cafeteria. You're going to stay down there with it. And that's where we stayed. The largest is about half the size of the Gemini. It's 4 meter. 4 meter. So you're looking a little more than 12 feet across. There's Jim. There's one of our astronomy ambassadors to give you an idea for scale. The Victor Blanco 4-meter telescope. Chris Smith, who is also the main administrator for all of Cerro Tololo, was the astronomer on that night. He said it's very rare he has time to get on the telescope, but he was excited. I got one night to work on some things. So in the control room, I've got Chris, our astronomer, over here. Here are screens. Here's our telescope operator. He's the guy who runs the telescope, makes sure everything's working okay. And looking off of Skype is another astronomer who contacted Chris and said, hey, listen, can I have the first hour of your observing run? There's a supernova. It's getting close to sunset. I'd just like to get another data point. He's like, yeah, my stuff's not coming up for a little bit. I'll do that. So they're talking and just making sure everything is set so he can get his data in. Here's a picture looking off the computer screen. The cameras here are they're amazing. Very, very complex. Each of these little squares here, you're starting to look at a different CCD camera. They're all combined to make one giant image. You're looking at Etta Carini, and we'll talk about that later. Take a look at that later. He happened to stop by just to show us. Here's Etta Carini. Take a look at this on his way to looking at some galaxies. Telescope. He knows how the telescope works. The astronomer collects the data. He's making sure the telescope is pointed in the right way, everything is working correctly, and especially looking at the weather. There's a little yellow marker on here, which is giving him the wind gust. If it gets to 40, he shuts it down, and not even the administrator sitting next to him can tell him, keep it open. He's in charge of the telescope. 40 is the limit. It was getting as high as 36. It was pretty windy that night. But it died down a little bit later. It wasn't too bad. But of all the screens, the one he was most interested in was this one, a laptop that he brought in himself. And that's where he's plugged into, because on here is a soccer match between Chile and Brazil. And he wasn't going to miss that for anything. So that to him was the most important screen to really keep watching. Chile won. Dark matter, dark energy. Galaxies have arms, right? Spiral arms. Some galaxies do. What we've noticed is that the stars at the tips of the arms and the stars further in the arm are traveling close to the same speed. That doesn't work. Because if that's true and that's what we're observing, the arms can't exist. They would simply break away and you wouldn't have any arms at all. But we do have arms. Therefore, there has to be some mass to the outside of those arms that's preventing the arms from breaking away. We can't see it, so we call it dark matter. We know it's there, because if it wasn't, there wouldn't be arms and galaxies. So it has to be there, we just can't see it. Dark matter is pulling the galaxies and trying to push them together. We found that there's something called dark energy, which is pushing them apart. So the universe is expanding and actually accelerating because we're ending up with more dark energy than dark matter. And this is really curious and a bit confusing. Some colleges got together and they said, listen, at Cerro Tololo on the 4 meter, we want to give you a camera to measure dark energy. We want to see a relationship between dark energy and dark matter, see how they're working. But you have to have the camera on. The deal is this. We'll give you the camera. You have to use it 105 nights a year. It'll take a look at a huge section of dollars. Like, we could do this. We could work this out. Some of the early results. So our first map traces dark matter of a large section of the sky. The color here is intensity. These are clusters, groups of galaxies. The larger the dot, the bigger the group of galaxies all pushed together. And we're starting to see how there's a connection between them with dark matter. Eventually, we hope to get about a third of the sky done in 5 years. You're looking at about 3 degrees of the sky in one image. Look at this, 74 CCD cameras all combined into one camera to take an image. This is this huge giant camera that they're using. They're doing really, really good research down at these observatories. I got 35 telescopes and I'm not using any of them. That wasn't our purpose. Every one is being used by an astronomer. We get to stay up there for 2 nights. We look up at the night sky. Anybody know the constellation? Go.
I know one.
Which one do you know?
Libra.
Libra. You're right. Libra's a good one. Here's the Big Dipper. And this, is, of course, is very famous for us. We love the Big Dipper in the nighttime sky. We check this thing out. And, of course, we find the North Star Polaris. We don't see the Big Dipper down there in Chile. That's not there. What we're looking at is the Southern Cross. Guys have it? Right there. Little dark area called the coal sack right next to it. And we can also use this to find the South Pole Star as we're going down. Now there is no South Pole Star. I set up a camera looking at the 4-meter telescope and I had to take pictures every 30 seconds for 2.5 hours. The moon was up, I couldn't do much anyway. I worked with a different camera. And then at the end I put all the images together and came up with this. There is no South Pole Star like we would have Polaris. We can see everything starting to spin around the South Pole. And there's the large 4-meter scope. I was really hoping to make an animation for you to show you the dome moving and changing as the night went on, because I can do that too. Since it was only 30 seconds, the stars wouldn't be smeared. All you see is really the dome closing because the camera broke that night. Their $5 million camera that they were using on the instrument that night just didn't work. Chris Smith, who was working everything together and he had that night, only had that night. He's the administrator of the whole facility and he's like, well, I'm done. I can't do the work. But that's how that happens there. That's part of the downside to it. Big Dipper, Southern Cross, we're connecting stars together to make patterns, right? Now, the Inca children, a long time ago, would look at the sky and they wouldn't connect the stars, they would connect the dark areas that you see in the Milky Way. And they would make pictures out of them. The biggest one is the llama. This one actually does have 2 stars for eyes. There's the eyes right there. Here's the llama's head. He's the drinking llama. Here's his neck and his legs coming down like this. But they look at the really dark patterns in the Milky Way to make their constellations. And the Milky Way, if you ever go to the southern hemisphere, that's what you want to see. That's the most spectacular part. The center of our galaxy is directly overhead. So we can see it in real good perspective here. There's the bulge of the galaxy, that's the center, and here's an arm coming down that way and an arm going out that way. It looks like a galaxy on edge. We don't get to see this from here. The center of our galaxy is always near the horizon. It's always at the edge, so we only see a bright spot here with a long arm extending out. But here we get the whole thing. So I'm out there, the moon finally set. I want to get this picture. Here's a 40-second shot, but I want a 5-minute shot. And so I took down a little sky tracker. And I put this thing on, I have the camera hooked onto it, and it's going to guide and work it across the sky so I can take a longer exposure. And it didn't work. I'm like, you got to be kidding me. I've been using you for a month and a half. You worked when I left. Did something happen on the airplane? I don't see how that could be possible. I'm looking at this. This is the best I'm going to get. I took it in, I'm looking, and here, I had the batteries out and everything before I packed it. But apparently a battery had leaked and it rusted up one of the contacts. And I found a can opener. It's the only thing I could find. I'm scraping away at this thing. And eventually I did get it cleaned up and it turned on. But it was a little later that evening by the time I worked it. So here's the center of our galaxy. This is a 4-minute exposure. This takes your breath away. When you're down there and you see the Milky Way, it is just phenomenal. That's the one thing that really makes your jaw drop and wow. You look at this thing in the night sky, it is just incredible. We got to sleep in dormitories that were set aside for us. Here they are. Ryan and I had this one in the end. You tell me you're going to be able to sleep when the sky looks like that outside your house? Really? I got no sleep in 2 days. I wasn't planning. I knew this from the start. This was going to happen. But I've got the Milky Way coming down low now. The moon is set, and we have the Magellanic Clouds just starting to rise here and here. The large and small Magellanic Clouds. That's the other thing astronomers want to see when they go to the southern hemisphere. We don't see them here. They are companion galaxies to our own Milky Way. By the way, at Cerro Tololo, they discovered stars from the Large Magellanic Cloud all the way out here, really far away from this thing. So it's much larger than they actually expected it to be. Here's the Large Magellanic Cloud. Here it is up close. Companion galaxy to our own Milky Way. Very blue, a lot of young star formation going on there. And the small Magellanic Cloud. This is a globular cluster, 47 Tucani. And the skies are just amazing. I'm tired. It's getting to be dawn sometime soon. I'm thinking we've had a good run with this. Let's start to clean things up. And I turn around, and that's when I see a few other things. Eta Carini. Remember Chris Smith was showing us a close-up of this. Eta Carini in the 1800s, for lack of a better word, burped. It was the second brightest star in the sky at the time, and all of a sudden it just burped and blew off a shell of gas. It's been hiding behind that ever since. We think that's the next star that's going to explode and become a supernova. Probably right there. Something happening behind that's probably already happened, it just hasn't reached us yet. Alpha Centauri, of course, we want to take a look at that. Right there. There it is, next closest star to the sun. And Proxima Centauri, which is approximately there, you can't even see it in this picture, it's so faint, tiny, tiny little red star, is actually the closest one in the Alpha Centauri system. And there it is. Dawn is coming. I turn around and I see this glow. And I'm excited. I haven't seen this glow since 2001. What you're looking at is something called the zodiacal light. I saw it in Africa in 2001. I've never seen it in the Northern Hemisphere. But you need a really, really good, super dark night. No light pollution around. And you'll be able to catch this. Usually better in the fall and autumn, or fall and spring, rather than the summer or winter. I've only ever seen it in the summer. So, what is a zodiacal light? Well, imagine the solar system. When it was forming, the sun goes across a plane. You have all the planets lined up, right? The light that's streaming out is lighting up. You're looking at ice and dust being refracted off of the sunlight, and it creates this glow. I actually had on my list this year, I want to photograph the zodiacal light. And I'm thinking, I think I'll drive down to Shenandoah sometime, and it might be dark enough to do that, or maybe over to Cherry Springs and try to catch it. And that was on my list, and I couldn't believe I saw it. So I was so excited, I kept taking pictures and pictures and pictures of it. And finally I decided I had to do something new with it, and I don't do this, but I actually took a selfie. And I'm like, yes! And I'm like, I can't move for the next 2 minutes. 1 alligator, 2 alligators, 3 alligators, 4. It was exciting. Our 2 nights went fast. Cerro, Tololo, into the abyss, looking out at the Andes Mountains, and here's the Pacific Ocean right out there. So we're getting ready for sunset. Just gorgeous. But our time is done. We've got to travel. So we hop on a plane. We go to San Pedro de Atacama, last observatory. San Pedro is an amazing city, town. Dirt roads, adobe brick church right in the town square. People are friendly, great shops, and dogs all over the place. Just like any place in Chile, they have dogs that are everywhere, and the town owns the dogs. They take care of the dogs, that kind of thing. Someone said, if you want to give somebody a gift from San Pedro, dogs. In this church, we just happened to be there for the rededication of this organ. This organ is over 100 years old. Actually, it hasn't played in 100 years. Nobody remembers where it came from or who brought it. They have no idea. And as we're standing there, one of the education public outreach people from ALMA, our next observatory, was standing next to me, and she's kind of whispering and translating the Spanish into English for me, so I'm hearing this stuff. And we had a little break in the action. I pulled out my smartphone and I pulled up a picture and showed her this. I thought it was the coolest thing. I'm walking down, there's 3 dogs just sleeping off a building. And she smiled and shook her head and she said, and she shows me this. The exact picture. So now we're both kind of smiling, and Tim's looking over at us, and he's the head of the ACEAP program for us. He's our mentor. He looks at us, and we're showing him the pictures of this. He pulls out his smartphone, and he shows us this. It's got to be like the most photographed dogs in San Pedro, Atacama that night. There's a parade they had, St. Peter Festival. What a great little town. And the area around it, oh my gosh, is so rich with things. Salt flats, the Valley of the Moon. We have geysers. We've got hot springs. We've got a meteor crater. We have pink flamingos, National Reserve for pink flamingos. We have ALMA. ALMA is a radio telescope facility. Atacama Large Microwave and Array. It has a low site and a high site. This is the low site at almost 10,000 feet, just under 10,000 feet. The high site is at 16,400. You can drive up to the low site as a visitor during visiting hours and get a chance to see what's happening here. When you get there, you're going to notice some things. You can see the Andes. I got a little volcano puffing over here. We have these UV ray indicators. Now this one's on extremo right there, which means if you have the white toned skin, you can be outside for 11 to 22 minutes before you're going to start to get skin cancer and glaucoma. If you have darker skin, you're looking 20 to 33 minutes. You're up at altitude. This gets to be a concern. You want to wear a hat. You want to slather on the sunscreen. They have models of the, well, actual radio telescopes there. This is what they look like. And they have to move them around. There's lots of them. There's 66 of them. They have two of these. This is Otto and the other's Lore. And they'll actually pick these guys up and move them into position. But they've got to be centered so carefully. If you're off by a quarter of an inch, it's useless, completely useless. This is a microwave tower. This is sub-millimeter. You can't be a millimeter off. So you've got to really position it very carefully using lasers and everything else. And they can do this. How do you observe? Same thing. I got this really cool project I want to do with ALMA. I want to take a look at this system of gas that's going around the star to look for planets. Okay, we like what you want to do. We see what you have. We've accepted this, and it goes to a software developer. He's going to take what you want and have the telescopes arranged when they're in the proper arrangement for your project. We will do it. You can come down to ALMA or you can stay at home. Doesn't matter. You can do either one there. If you want to visit, we've got dormitories and that stuff if you want to be there to see it happen, or we'll just send it to you when it's done. And the software developer actually runs the telescope. He makes sure the software is running correctly and everything on the computer is looking good, checks the monitors, and your work is good. Here I am with my college roommate a few years back at the top of Mount Whitney in California at 14,500 feet. This is the highest spot in the continental United States. I've been over 14,000 feet at altitude a dozen times in my life, 12 times in my life, but now I'm going up to 16,400. And I know at 13,000, my head starts to really hurt. I feel a little nauseous in the stomach, and I got to rest and relax, plenty of fluids, and eventually after a few hours, it all disappears. And I'm like, I'm acclimated. I can start to move further. We are going to go from 10,000 feet to 16,000 feet in half an hour. I'm thinking, this is going to be interesting. Before you can do that, you have to get a physical examination. So they have medics down below at the 10,000 foot mark, and they're checking things out, and they're looking at your oxygen levels, your blood pressure. They're checking, make sure everything is okay, then you get cleared to go. Our last checkpoint before they let you up that road, they're making sure that the people are all cleared medically. You need to take it slow on the road because as you go up in altitude, your reasoning may start to waver. You might get tired. You need to be careful. We saw some llamas. That was kind of cool. And there it is, 16,400 feet. Our first view of the Large Telescope Array, all these satellite dishes. So what was it like when we got up there? Everything seemed fine in the car, and I realized, yeah, Okay, yeah, my head is pumping and I'm having trouble, I'm feeling nauseous because I'm hiking up with a backpack. I'm sitting in a car doing nothing. I'm not feeling any of that. My head doesn't hurt, nothing feels bad. I'm at 16,000 feet in half an hour, no big deal. But then we get out of the car and we all went crazy. Actually, we're all happy there. You do feel a little weird and wobbly when you get out of the car, and it's not bad at all. Traveling at 16,000 feet up at Alma is not a big deal. They bring you in a big facility and they give you orange juice and cookies, like you just gave blood. And they monitor you constantly, even when you're up there. Let me see where you're at. What's your oxygen level today? What are we looking at? If it goes down below 80, we're going to actually put an oxygen tank and put the tubes up your nose and constantly turn oxygen on. But if it's not, just use one of these. Take a puff now and again of oxygen. You guys can share a canister and just take a hit and just you'll be fine. And it's not a big deal. That's a computer. That's at 16,400 feet. We call it the correlator. What you're looking at is the second fastest computer on the planet Earth. You have to have this in order to run all these things accurately. What are we looking at? 32,768 computer chips. It is capable of performing 17 quadrillion operations a second. It's like 3 million laptops hooked up together. That's what you're looking at. They drove us out. They said, don't move very far from the ambulance. Yeah, they had an ambulance follow us up too. You're on some of the radio telescopes, take some pictures, and walk around the highest observatory in the world. Why does it need to be up here? We don't want any water vapor. There are parts of this desert where they haven't recorded rainfall in over 400 years. This place is dry. And for the measurements on these things, which is so sensitive, we have to keep moisture away. If it does get up a little bit high in the moisture end, there's not a whole lot they can do, and they've got to kind of shut down for the night. That doesn't happen very often. And of course, it's a radio telescope that can operate day or night. This thing is 17 kilometers in diameter. It's a gigantic eye. It's huge. And even though it's looking in radio waves, it really can give us some detailed looks at the universe. Look at this picture. That's a radio image. That was taken at Alma in February. You're looking at the birth of planets. What's happening here in the center is a star is forming. Now when the star forms, a lot of the gas goes onto the star, right? But then as the star is cooking, it's not burning yet, it gives a little back pressure. And all the other gases that are moving around it can't fall on it, so they just kind of swirl around, and some pieces start to hit together, and as they get bigger and bigger, we call it planet building, these collisions. They start to carve out a path, an orbit, as they go through. So all those dark lines, there are planets that are forming in there that are carving out their orbit. You're going to have terrestrial Earth-like planets forming closer. You're going to have the gas giants that are forming farther out. This is the most fantastic, best image we've ever seen of planets forming. The resolution on this, the sharpness, the detail is better than the Hubble Space Telescope. ALMA is an amazing facility. Those are the professional observatories. You guys are at an amazing place here. I was given a tour. This is very impressive. The detail that you guys have here with your displays and the telescopes, gorgeous. In Chile, with their beautiful skies down there, they take advantage and they call it tourist observatories. If you're a tourist down there, you can go to one of these observatories to actually do imaging and look through the telescopes, because you can't do that at Cerro, Tololo, or Gemini, or Alma. You can visit during the day, but not at night. This is a tourist observatory. Imagine this. This is when you walk in. This is the Observatory Andean Astronomical. It's about a half hour out of Santiago. When you arrive, Lots of tables outside. They got lots of fires going. Lots of really beautiful artwork. And they take you in the main building. And they will give you wine and cheese and pastries and chocolate. And they have all sorts of displays up. There is a room where they'll talk to you, similar to this. They got the projection screens, all that stuff. They'll have another large screen. They'll just show the night sky as you can see it out there. Another one showing beautiful images taken by different telescopes. And when you're ready to go outside, really nice touch. Everybody gets a poncho to wear. Put on this giant poncho. And you walk outside and you use the telescopes. They got a bunch of them on piers. If you get cold, walk over by the fire. There are nice chairs to sit in with binoculars, or have your drink next to you and kind of look at the sky if you're not there. They got a huge observatory upstairs, roll-off roof. It has 3 giant telescopes, a Meade 16, another Meade 16, and a Celestron 14, all set together there to look at the sky. And you're there for the evening. That's one. And how it works is you would pay them. It's not open every clear night. You get together as a group and you'd say, we would like to use your observatory. Here's the fee. You pay the fee. They take care of it from there. This is the Mayu Observatory. This is their dome, wooden dome. And again, this is more of a archaeology kind of motif to it, archaeoastronomy. Again, another big viewing room right in here in order to see different things. Beautiful. And the main observatory itself. But I like the area outside of it. If we move up the path, up the mountain, and we can see the dome is open. See some of the southern skies and some of the landscape. So start to walk up that path, and let's look in this direction. They've got some really cool stuff up here. Looks like old buildings that were from some pre-Columbian era. And sculptures. There's a line of them. There's 5 of them. Now this one, of course, looks kind of like a snake as it's coming down. But they're all functional. There is a hole here that when the sun is at the equinox, the light comes down, goes through it, and shines right here onto the tail. And they put a flashlight down there to show us. Each one has a specific function for the seasons or for something to show astronomically. And they're all lined up on a south to north line, a meridian. You want a career working with the universe? One thing we've learned, if you want to learn about the universe, you can be an astronomer. You got the math and science stuff, right? You're analyzing, collecting data. But we also need telescope operators. These are the guys who really work the telescopes. Astronomers do not. You've got people who are trained to work them, and that's what they do. Software developers are needed because of all the computer work that's done today. Administrators are necessary to make sure everything's running smoothly and get funding. We need engineers and opticians. These are the people who are going to design and build things for you or give it to the machinist to make. All these people are necessary to run an observatory. How about this guy? Documentation. Got that library science degree? Everything has to be documented. He archives everything. Everything. He's so efficient at this, he can even balance an orange in his head while he does that. Look at that. And EPO, Educational Public Outreach. These are the people who write the press releases, set up the displays, have talks to the public. This is all their stuff. And of course, Astronomy Ambassadors. This is the first year we've had this. There's our team of 9. Tim, our mentor. They're planning on doing it for quite a few years. So it's the kind of thing that, if you're interested in it, apply for it. We're done. They went home. The 3 of us decided, hey, we're here. Let's go to Rapa Nui. You may know it as Easter Island. Let's take a vacation. like spending some time on a white sandy beach with palm trees and giant heads. You can't beat it. However, there is only one white sandy beach. Most of the island on Easter Island really looks like this. So it's a volcanic island. So you don't really have the beaches like that. Just one. Lots of volcanoes. Lots of wild horses running all over the place. Of course, it's owned by Chile. There's wild dogs. Well, not wild. They're domesticated dogs all over the place, too. But the heads, right? This is kind of the head factory. It's up here at the top. They build the heads and they would walk them down to different parts of the island, but that's a volcano that they really come from. Here they are for scale. That's the three of us. That's Ryan, Vivian, and myself. And you think of the heads just looking like this, but that's really not the case. There are very, very few of them that look like that. Most of them have bodies. And sometimes they line them up. When they were done, they would also have eyes. As you can see there, they would carve them in so that they would actually have eyes. And usually hats. Their hats are missing. And they don't like you stomping on the heads. Gives them a headache. Just don't do that. One of the things I thought was interesting, since we're looking at politics and all sorts of stuff, on Easter Island, to decide who was going to run the island for the next year, they would parade all the people who were interested at the top of this volcano. And at the start, they would all run down this hill, dive into the water, swim out to this island, climb up, find a bird's nest, grab an egg, carefully take it back, get off this island, swim all the way back, climb up here, and the first person to get back without breaking the egg, they get to run the island for the year. Their group runs the island for the year. That's how the politicians do it on Easter Island. I don't think it's possible to take a bad night shot with a giant head somewhere in the scene. It's just gorgeous. This is sunrise. 15 of them all lined up. South Pacific Island, paradise, right? Sunrise was at 9:06 in the morning. I don't know. They even arranged sunrise so you could sleep in. And it was just really odd. Perfectly preserved moai, that's what they call them, moai, M-O-A-I. Eyes and the hat. And they keep this one set up. This is just outside of town. It's very easy for me to image. And you're looking again at Venus and Jupiter. This is on July 1st when we had arrived. It was around full moon. The sky's going to look very blue. And again, I set the camera up to take pictures for a while, and the clouds started to move in, which gives it a nice contrast there, but you'd never have an observatory here. You're going to have it completely clouded up like every 45 minutes to an hour, and then it'll be completely crystal clear, and then some more clouds will come in. Can't get a whole lot done. But again, no southern star. And I like the blue background because the moon was up, and it kind of lights up the moai. I did try it the next night before the moon got up. No clouds. Kind of impressed by that. Not a lot of light pollution. Again, looking off their major city, it's not that far off. Again, no South Pole star. My mistake here is I should have kept going. When the moon came up, I stopped, and that really would have lit up this moai a little bit better. A lot of thanks. A lot of the pictures I took, others have been contributed by members of the Astronomy Ambassadors and by the staff, Gemini, Cerro, Tololo, and Alma. And of course, a tremendous amount of thanks to the National Science Foundation for funding this and making sure this is a reality and continuing this program. And to the people of Chile. Only some of their pictures are here. But my goodness, you're not going to find a friendlier group of people who are enthusiastic and really want to share astronomy and tell you what it's like in the southern sky. This is a tremendous place. The next time you go out at the sky or look through the telescopes here or somewhere else, make it a goal to learn something new about the universe. and maybe something new about yourself in the process. And keep looking up. Thank you. Thank you.
Are there any questions for Peter?
Please.
With the Gemini telescopes,
Yeah.
you were describing, the manipulation abilities on the one on the south. Is the one in Hawaii the exact same?
The exact same thing. Yeah. Same mirror, same adaptive optics, everything. They want them to be the same. Yeah. Have the same capabilities. Yeah.
So who built that computer with 32,000 chips in it?
Who programmed it?
Or who built it?
Who built it? The correlator. I'm not sure who actually manufactured that. ALMA is an interesting place. The United States has brought a lot of technology down there, but also Europe has stuff down at ALMA as well. They have radio telescopes there, and they're different sizes than the ones we have, which gets a little complicated sometimes. And you're also looking at Asia coming through. So I'm not sure if the correlator was something that we actually brought the technology in and put together down there, or if that was a combination between us and Europe and Asia as far as that goes. Not sure who actually built it.
What cameras did you use for the night shots that you took?
I'm sorry?
What camera did you use for the night shots you took?
Oh, the night sky shots that I took, what camera did I use? Canon 60DA. Canon 60DA. Yeah.
Which is a good month to visit Chile for this?
We went in June and early July. Actually, the Andes was just in June, which is the beginning of our summer, but it's the beginning of their winter. That's the coldest it's going to get down there. And they're about 30 degrees south and 27 degrees south. So you're looking somewhere around the latitude of Miami and maybe southern Georgia kind of thing. So it's not too bad as far as that. And even though you're up high in the mountains, the temperature at night didn't get much lower than about 30 and typically in the 40s, really. So it wasn't bad. It was a very nice time to visit. I think any time of year is really good to go down. Yeah. I mean, that would be your worst case scenario in the winter, right? If you like skiing, that's when you want to go down there too. Yes.
Fantastic presentation, amazing pictures. I have one very
Thank you.
simple question. One of
If I
your
could ask
amazing
everybody
pictures
just hold their seats for a couple minutes so we don't all start drizzling out. It's important.
of the
Thank you.
small and Magellanic Clouds and the Milky Way, was that a process shot, or is that what the sky looks like there?
One shot, one picture, one pic.
Wow.
And with the Milky Way and with the building in the foreground, 40-second exposure on that, because I didn't have that guided at that point. That's a 40-second exposure. Yeah. Amazing.
I have a related question. How can we, the public, get access to those images from the ALMA Observatory? There.
You can.
You can't?
You can. You absolutely can. And it's incredibly complicated. I mean, if you're a software programmer and you understand what you're doing with it, they had us down there and they said, okay, let's look at this. And we'll take you to the website. You go to the website and just ask for data. They'll have a thing for data and you can click on that. But it's not like, I would like to see the Orion Nebula. No, there's a whole number kind of jargon you've got to put in order to figure it out. And it's not the right ascension declination, but it's going to be a number that they all understand down there, but you may not. But that will bring up your data. And make sure you got a fast computer because the files are huge. So, yeah, you can collect that because it's public domain. You can do that, but it's a little complicated. Go to Gemini Observatory. Their website is amazing. Go to Cerro, Tololo, CTIO. Really, CTIO. And ALMA is a really good one. And you'll be able to see where their data is. And they'll show you the latest images from it. You can catch up. Here's the latest stuff we've done with this. But you can also access the raw data. If you can figure out that or have the time to spend and say, what is this thing? Let's go find out.
Thank you.
Yeah.
Excellent presentation.
Thank you.
Okay, hold on one second. I'll be right there. Just one